In this video, we'll practice writing chemical formulas. When we write chemical formulas for ionic compounds specifically, a couple things we want to keep in mind. First, we want to write the symbol of the metal and its charge, followed by the symbol of the nonmetal and its charge. Second, we want to make sure the magnitude of the charge on each ion will become a subscript for the other ion. And don't worry, we're going to practice this and see it on the next slide. Third, if it's possible, you want to reduce the subscripts to give the smallest ratio possible of whole numbers. Important fact, they have to be whole numbers. You can't have partial numbers on this. You can't have 1.5 or 1.5 atoms. We're not splitting atoms apart here. And then fourth, you want to double check to make sure the charges will cancel each other out. So that way the overall charge of our ionic compound is 0. So we want to make sure the number of positive charge and the amount of negative charge are the same. So looking at those rules, and particularly number 2. We write our metal, magnesium in this case, and our nonmetal, nitrogen. Magnesium, if it loses 2 electrons, has this noble gas configuration, so that's how you get a +2. And nitrogen, if it gains 3 electrons, has a noble gas configuration, so it's -3. So what you do is you take that charge from one side, so you take the charge for magnesium, the +2, that becomes the subscript for nitrogen. And then that charge, the -3, the 3 becomes the subscript for magnesium. So that's how we get Mg3N2. One thing to note, if you look at it, the charge, the plus or minus, that goes away. Only the number of it stays. So that's how we get Mg3 and not Mg-3. And we can double check to make sure these charges cancel. When we write the formula Mg3N2, what we're saying is there's 3 magnesiums, each with a +2 charge. And you can write the plus in front or behind, it doesn't matter. And then there's 2 nitrogens, each with a -3 charge. So if you add all that up, add up the charges, +2, +2, +2, gives you a +6. You can do the same for the nitrogens. -3, -3 gives us a -6. So +6 and -6, they'll cancel each other out. That's how I know this is a good formula. So now let's look at a few more examples. If we look at sodium chloride forms a +1 charge, and chlorine forms the -1 charge. +1, -1, they cancel out, so it's 1 and 1. And then we look at calcium nitrate. Calcium forms a +2. Here, each nitrate forms a -1 charge. So that's how we know we need 2 nitrates to cancel out that +2 charge. Or we can look at sodium sulfate. With sodium sulfate, our sodium each forms a +1 charge, so we'd have 2 sodiums. That gives us our +2. And then sulfate, you see, forms a -2 charge, so I only need 1 of those. And then one other one I want to point your attention to is barium phosphate. If we look at the formula a little closer. For barium phosphate, we have Ba3PO4 2. Notice there are parentheses. We use parentheses when we have a polyatomic ion. If you remember your polyatomic ions, they always act as a unit and act as one group. So we always keep them together. And so if we remember or if we look at our list for our polyatomic ions, phosphate, PO4, has a -3 charge. Barium, if we look at the periodic table, forms a +2 charge. So if we do kind of our switching and our crisscross method, I know I should get Ba3, and we do the parentheses so we indicate the phosphate is all together 2. If you don't do the parenthesis, then what that would look like is Ba3, PO4 2, and that almost looks like you're saying there's 42 oxygens. So we need the parentheses. Without parentheses, it looks really weird, as you can see. And so what this really indicates, and what the parentheses indicates, the 2 on the bottom here indicates that I have 2 phosphates. So if I were to draw it out, I would have PO4 -3 and another PO4 -3. And then I'll have 3 bariums to go with it. +2, barium +2, barium +2. So that means you have an overall +6 charge, and my 2 phosphates give me an overall of -6. So once we know the charges of our elements or polyatomic ions, we can figure out what the ionic formula should look like. And remember, if you have a polyatomic ion, you need the parenthesis to indicate how many of that particular polyatomic ion you have.